Hi there, I'm Captain Steve of the SV Horizon Star, and we're currently lost at sea right now. That's me on the left there, and that's my first officer, MCToon. He's given me these sextant readings, so hopefully we'll be able to find where we are and get back on course. As a captain of a ship, it's my responsibility to bring a flat Earth model on board. This is how we would navigate through the ocean. Even as a pilot, when we fly planes, we always have a flat Earth model with us on board. So, luckily, as a responsible captain, I believe I can get us back on track. And thank you to the certified sextant operator, MCToon, for giving us these readings last night, because it's my fault we're off course. I got drunk and I don't even know where we are right now in the ocean. We could be anywhere. Now, luckily, though, I do have a flat Earth model, and very basically, I want to just explain how it works. You can look up the locations of stars, and you'll get a right ascension and declination. You can look up Arcturus, Regulus, and Dubhe. For example, Dubhe has a declination of 61 degrees. That means it is going to be on the upper half of the dome firmament and then projected down onto your celestial sphere in the exact same way. So, for those of you who don't know about celestial mechanics, the top of the firmament has a declination of 90 degrees, the bottom has negative 90 degrees. So, this is how astronomers track the location of objects, and they move up and down the dome firmament, and then right ascension is how they wrap around, and it's actually measured in 24 hours. So it makes perfect sense to me. This is how I would quantify a flat Earth model. Now I can show you guys the code, because a lot of people are going to be like, "Oh, it's a globe model," but all it is your spherical field of vision, and we see in little domes. That's inarguably you're going to see in a little dome around you in your azimuth 360 degrees and then up and down 90 degrees. This is how you see. So then from that, we know that if an object has a declination of 90 degrees, it'll be at the very top of this little red dot right there. So that's the top of the firmament. See right here? That's the top of the firmament. So declination 90 is right there, and then as it descends, it goes lower and lower. So it makes a lot of sense to me. This is how you would navigate. It's how you would make an astronomical model. Even apps like Stellarium, they copy this exact same thing. Everything is from a flat, observer-centric viewpoint. And then throughout the day, it moves around from our perspective. Stuff sets and rises. So like this is just how celestial mechanics work. Now what we're trying to do, though, is get our course back on track. If you actually see those three blue dots, I put our stars into the system, and if you actually notice, see how it says locked on the left hand side. Let me see if I can make this bigger. I don't want to cut off too much, but see that green text saying locked on? This is how I would do a 3-point star fix. You navigate around and find out when you're locked on. So let's increase our latitude. Okay, see how we're not locked on anymore? Let's try adjusting the longitude going around. Let's go maybe a little up. So see how we are getting locked onto stuff? So let me set the time correctly. 8:30 GMT is going to be 3:30 Central Time. And GMT is the same as UTC 0 for all you who aren't familiar. So let's set the flat Earth model to 3:30 a.m. And as you see earlier, all time is its right ascension. That's how they took our flat Earth and wrapped it around a ball. You'll find a whole bunch of coincidences like that, and to me it's beyond a reasonable doubt that this is the accurate depiction of the world. I don't really see any other way. If you try to wrap this around a ball, it doesn't. Like, and I have a globe myself. I study this stuff. It makes no sense at all, except a flat infinite plane. Remember, it's an infinite plane. We're not floating in space. But let's get back to what is important here. So Let me make some more space. So now that we've set the date, November 15th, 2018, 3:30 a.m. Now, see these three stars? All we're trying to do is figure out their angles from the flat Earth. It's right angles, and again, that's another reason why I argue if we're I do not know how to do it on a globe, because then you don't have a right angle. And I've looked into it a little bit on the globe, and I think they use stuff like dip tables, and you have to correct for what they did by wrapping it around a ball. So for us, we don't need to do that. We're using the actual real model, the true depiction of Earth, and we can simply do it with right angle triangles against our flat Earth. So you see these three things. What we're trying to do is find the longitude and latitude where we get the measurements we need. So see right here, it now shows that Dubhe and Arcturus were locked on now. That's amazing. What we're exactly looking for, though, is going to be Regulus. So it would be wrong for me to say that we are in the North Russian Sea just because Arcturus and Dubhe are close. And let me see if I can fine-tune that just to get as close as possible. Yeah, okay, so we got to 25 for Arcturus. Now let me go back, actually. 27 for Arcturus, and then for Dubhe we're at 54. So, but we need to do a 3-star location. But you understand the logic here. So now that we have flat Earth models in modern days, this is one of the reasons why it's so easy to do celestial navigation. What we'll do is we'll just write a very simple function. So we're calling this function MCToon after our first navigator who gave us these readings. Without him, our ship will still be off course and we would be lost at sea and completely screwed. All we do is we go through every possible latitude and longitude and then see if the right angle triangle from our flat Earth matches what we're looking for. So in my code, I did a plus or minus 5 degree. And if we get a match there, I can then manually adjust it to see where it'll exactly be. And as you've seen before, it shows us our latitude and longitude up here on the flat Earth model. And just to show you guys the time still, it's still up there, so everything's fine. So let me, I guess, just run the function now called MCToon. So we're going to click this. Let me focus on the observer.
Now I know the Earth is flat because I've studied all the science. And now I know more than all the scientists. Flat Earth, Steve.
So all we're doing is we're just going to now navigate through it. So let me see if I can put on the location. Yeah, so see how we're going down longitudes now? And this might take a while. I said it's slow, so it will, like, normally you don't need to display the graphics. You just automatically calculate this. This is how technology works on modern ships, airplanes, any vessel. This is really nice. So let me turn off this, because I want to... Oh, I have to zoom out maybe to get it back on screen. Can I turn off the sun and moon? I don't want that covering. No, I want to fix the UI then. I don't want to see the sun and moon information, but it looks like we have to. But there's going to be about 8 or 9 stars that I've plotted into the system. And again, there's nothing based on a globe. This is your perspective. So, for example, the sunset. I assume most of you don't actually believe the sun is setting and rising from the actual water. As you know, it's about a mile for every 69 degrees. So even though the sun's up here, the farther it gets from you, it's going to go through there. Now, I'm going to let this program just run and see what it finds, if it even does find a valid location, because... Like, see Regulus here, is it going to lock on? I just want to see if it shows locked. Yeah. So see how it's showing locked on in the green? What happens is when 3 locations lock on, this will stop. And it'll log the longitude and latitude that we're at. So, yeah. I'll check back in a little bit and let you guys know where we're at. So now I'm wondering if it's even possible. Because I'm only getting double matches. I'm not getting more than 3. And you see the geometry, right? So right now we have Dubé and Octurius up where they need to be, but we would then need Regulus, which is this small little one down here, to go to 70 degrees. Is that even possible? So now I'm just trying to think about it. If we were to keep, let's say, Dubé where it is, Octurius where it is, how can that work? Right? Because we have to be in the northern hemisphere. We know that no matter what. So we're above the equator. That means this should be very easy to brute force. Like, let me go over here. Like, let me play around with the geometry. On the right-hand side, if you see a red, that is what we're looking for. But I don't know if it's possible. Because look, if we put Regulus up to 70 degrees, see Regulus is now locked on over on the left-hand side. Let me zoom up maybe a bit more. And let's turn off the date. So Regulus is now up at 70 degrees. But Dubé is now way too low, and Octurius is too low. So, yeah, it doesn't make sense. So I am going to have to go through MCToon's videos to see if anyone has actually submitted the right answer. Not the methodology. I know no one's ever, or no one will ever actually fulfill the challenge. But what is the actual location? Like, is it even possible to do that? Because I don't think so. Okay? Like, where could it be? Like, even if we just brute force it, there's no possible location for it to be. The only possible scenario is if there is a trick, which I might not be surprised. So, index error, true bearing, temperature, and pressure. Is that going to adjust the angles enough that it actually matters? Or was that just put there for us to calculate the precise latitude and longitude by like maybe 5 significant digits? I don't know. So if I cannot find a location, ignoring all of that, that will be what I do for my second attempt. Because right now you see what I'm doing, right? It makes perfect sense. These are the angles that he gave us, and they would all have to be above what I think is an impossible thing. I don't know. I could only get a double match. Now let's go to the equator and just be weird. Because is it even possible on the equator to do this as well? I don't think so. So what stars are there? Yeah, no, so along the equator, it'll never be more than a single match. Yeah. You see that? And then let's move to the maybe 10 degrees. And then let's go back. Sorry, I think I broke it. there's a lot of calculations going on behind the scenes. Let's reload this. Set the date to November 15th. Time 3:30. And yeah, let's get back to this and not slide the date as fast as we were doing before. So let's do it at 15 latitude. Oh, then let's go to 10. Let's go to 10. Let's brute force this together just so you see that I don't think it's possible. Yeah, so it's only a single match. Green means a single match. Let's go up to 20 degrees now. Single match. Single match. Single match, yeah. Let's go to 30 degrees. Okay, we're in a single match zone. Double matches. So there's a double match right around here. But can we get a triple? I don't think we will ever get a triple match. Nope. So let's go to 35 degrees, just slightly more. And yeah, let's head back. Double match. Yeah, no, so the only place I've ever got good luck is right along here, and then as we get to the North Russia Sea. That seems to be the hot spot, but let's go up to 40 latitude, and let's go back along here. Yeah, no. So let's go up to 50 degrees latitude. Nope. So let's go up to 60 degrees of latitude. Is it freezing again? Yes. I have a whole bunch of... It's a publisher subscriber base, but an RxJS, we call them subscriptions, and it's really, really nice because I can change something like anything on the UI and have something deep in the code kind of just react to that. But I gotta clean all this up. And actually, it could just be what I just did now. Like just a couple hours ago, I implemented this celestial navigation thing. So that might actually be what's breaking everything right now. But let's go to 3:30. Turn off the sun, get the planets and stars. Yeah, so let's put our location up to 50. No, let's go to 60 degrees. 60 degrees and just rotate that around. Yeah, single matches. That's what I mean. There's the only double match I really got is right around here. So if we're at this location here, there's a double match. Let me take a screenshot of that. Because if I'm doing something wrong, I want to learn what I'm doing wrong. And I'm not even sure how many flat earthers have attempted this. But the North Russia Sea is one spot. And then I think right over here, like in like Toronto Sea. Let me go to where I think another double match was. Yeah, so right here, there's another double match. Let me rotate that around. Let me screenshot this as well. Make sure, actually, I don't think I had the GPS in the last screenshot. So let's go back to the other one. So North Russia Sea, that was like 80. And then over here, yeah, so the North Russia Sea around here. So, one sec, let me... You want to see the right angle triangles just so people don't think I'm crazy. Nice. Yeah, that's good, Because that's how we do celestial navigation. The angles given to us up here are the angles of the horizon. Like, and that's the thing, I'm not just making this up. Like, you can check this in Stellarium. So let's do that just before we end this then. Okay, so using Stellarium, let's go to the Kara Sea, which is roughly the closest one you can go. These types of platforms are limited. You can't actually type in the GPS like you can on a flat Earth model. But let's go to what we're trying to do. So November, December, so the 11th month and 15. At 3:30, because for me I'm in Central Time, and Stellarium will be looking at the JavaScript date object, which will be in your user's time. So let's just search for Regulus, just to confirm that it is 10 degrees from the horizon and that it's not possible to actually solve this challenge. So yeah, you see up here, let me see if I can... yeah, so see how it's 5 degrees from the horizon? That makes sense, because we're at 73 degrees latitude at the Kara Sea. So let me just put my latitude to 73, and you see how Regulus now, 5, hold on. What is the Kara Sea exactly? 73, and longitude 71. Okay, yeah, so now Regulus is down to that 4 degrees from the horizon. So everything I've been doing for the last 20 minutes is sound. This is how anyone would have to do it. So even if you use Stellarium and tried to do the exact same thing I did, it's going to take a lot longer though, but you will never find a location where all 3 stars match that location. And let's just see right now, Dubhe. It is 54 degrees, matching my 53. It's roughly. And then Arcturus, 27, matching mine. So yeah, everything the Flat Earth model predicts is exactly what Stellarium claims, except they're limited to the first person view. They don't actually let you zoom out and see what it looks like in real life. So that's why... I don't know, like, what is wrong with this challenge? Is it possible, or is it going to be this stuff that is causing the issue? And that's the whole trick, because it's not just the basics we're thinking, it's going to be something much more complicated. That's interesting. So yeah, this is what I'm going to look into next. At the moment, I do not believe it's possible. If anyone has actually submitted the location, we can verify where it is and see, but I don't think that's possible as of my knowledge yet.